Leetcode problem 3148, maximum difference score in a grade. So we are giving a 2D grade, and we can only go to the right side or go to the bottom side. So for example, this is the grade, and we can only go two directions. We can go to the right side, or we can go to the bottom side. Let me just clean it up a little bit. So we are giving this kind of grid, and there will be numbers inside of the grid. And for each of the time, we can only go to the right side or go to the bottom side, but we can go not even one step. We can go many steps. So for example, first of all, we are at this number 5, and we can go 2 steps to this number 7, and then go 1 step to this 14, and then we're going to have the maximum value. It's going to be 7 minus 1 plus 14 minus 7. So what is the result? So it is 14 and minus 7. So what is the result? So it is 7 plus 2. It is 9. Yeah. So now the problem becomes giving a current point, for example, at this position, and we just want to check all the positions just before it. It means at the left side of this dot and at the top side of this dot, and of course including the diagonal side, but it is always in these areas. So currently I'm at this position. I want to check the minimum value in all those positions. Maybe this is 1, this is 2, and this is 3. So the minimum is 1. But currently I'm at position 4. So my result going to be 4 minus the minimum value of the 3. 1, 2, 3. It's going to be 1. So 4 minus 1, it's going to be 3. So this is going to be my result at current position. Maybe here I have a value 7, but my minimum is still 1. So my result is going to be updated to 6. Now we just need to prove, can I jump from this 1 to this 4 directly? As you know here, we can go from 1 to 2 and 2 to 4, the result going to be 3. And we can also go from 1 to 3, 3 to 4, the result going to be 3. Yeah. But currently, all those numbers like 2 and 3, it is bigger than 1. But what if the numbers is smaller than 1? So for example, this number is minus 2. Is that also work? It also works. So this means it doesn't matter if this number is smaller or bigger, it doesn't matter. I only need to compare this number 1 with this number 4. Let's just use an example. So for example, this 1, currently this number is minus 2. So we're going to use minus 2 minus 1. So minus 2 minus 1. So the current value is going to be minus 3. Now we're going to jump from minus 2 to this value 4. So it means 4 minus 2. So what is the result? So the result is 6. Yeah. So 6 plus minus 3. So it's going to be 3. As you can see, the result is going to be the same. So this means it doesn't matter if it is diagonally or if it is go diagonally, it also works. Yeah, because we can jump from any other places, and we got the same result. So it means it doesn't matter. So this is like we are climbing a hill, and this is the top of the hill, and this is the lower point of the hill. Yeah, and during the process, maybe we go, for example, from here we go down, and this is the lowest point, and then we go to the hill, the top point of the hill. And then we just need to compare this point with this point, and this gonna be, this gonna be the final result. Yeah, because we just approved. It doesn't matter if I go down. It doesn't matter. I just want to compare this minimum point to this maximum point. Yeah, but I need to check that for my current position, I have to compare with all the previous positions, but not included myself. Yeah. So while I'm checking the 7, I need to check all those positions, but not include this 7. So this means we can solve it by dynamic programming, and specifically it is the prefix sum. But for this one, it is the prefix minimum value. Now let's try to solve it. So we're going to prepare R and C as the row and column of the grid. So it's going to be length of the grid and the length of the grid 0. And then we're going to prepare a DP table. So F going to be infinity, because we're going to check the minimum value from before. So times R plus 1 times C plus 1. So for R in range, R plus 1. Now we just need to check, but before that we just prepare a final result. So we define it as negative infinity, and because it can be negative values, so we're going to prepare a minimum value. Now we just need to loop through it. So from 1 to r plus 1, and for c in range from 1 to c plus 1. Now we want to check the previous minimum value, so it's going to be the prefix sum. According to the DP table, it's going to be the minimum of f r minus 1 with c with f r c minus 1. So this is going to be the previous minimum value. Now we want to check the result. So our result is going to be the maximum of the result with current value. It is grade r minus 1 and c minus 1 minus the previous minimum value. Now we want to update the DP table. So frc is going to be the minimum of my previous minimum value with the current minimum value. It's going to be grade r minus 1 and c minus 1. Finally, we just need to return the result, and this is going to be the entire code. Now let me just check it works and submit it. Yeah, as you can see, it works and it's pretty fast, and the time complexity is m times n. So this is the row and column, and m times n is 10 to the power of 5. That is why it works. Thank you for watching. See you next time.